Hey everyone, here's the top 15 most earthquake-proof structures in the world. Starting with number 15, the Transamerica Pyramid. The Transamerica Pyramid is one of the most recognizable buildings in San Francisco, California, and it's not just a landmark, but it's one of the most earthquake-resistant skyscrapers. It stands at 260 meters, that's 853 feet tall, with 48 stories. This uniquely designed structure was built to withstand the earthquakes that frequently strike the San Andreas Fault Zone. The building's ability to endure seismic activity has been put to the test multiple times, including during the 1989 Loma Prieta earthquake, proving its remarkable engineering. From a satellite perspective, the pyramid is one of the most striking features of San Francisco's skyline. It's got a distinctive shape, and it was designed by architect William Pereira, not just for the aesthetic appeal, but its critical role in earthquake resilience. Unlike traditional rectangular skyscrapers, which can sway violently during seismic events, the pyramid shape helps distribute seismic forces more evenly, reducing stress on the structure. Now, one of those resistant features is the steel-reinforced concrete foundation. It extends deep into the ground, which anchors the structure securely. This deep foundation is essential for withstanding the liquefaction effect. This is a common issue in San Francisco, where the soft soil can behave like liquid during an earthquake, which will destabilize buildings. To counteract this, the foundation's embedded 15 meters or 49 feet deep into the bedrock, providing stability even in the event of intense ground shaking. Another important feature is the steel frame. The pyramid is designed to sway up to 30 centimeters, that's about 12 inches, in any direction during strong seismic events, absorbing the energy and preventing any catastrophic damage. The Loma Prieta earthquake, which struck with a magnitude of 6.9, caused widespread destruction across the Bay Area, but the Transamerica Pyramid emerged unscathed. Over the years, San Francisco's continued to improve its infrastructure, but the Transamerica Pyramid remains a benchmark for earthquake-resistant architecture. It shows how engineering innovation can coexist with aesthetic design, proving that tall skyscrapers can be both visually striking and structurally resilient in one of the most seismically active regions in the world. Number 14. Taipei 101. Taipei 101, once the tallest building in the world, was one of the most earthquake-resistant skyscrapers ever built. It's located in Taipei, Taiwan. This 508-meter, that's 1,667 feet, it faces some of the most extreme natural forces on Earth, including frequent earthquakes and powerful typhoons. Yet, thanks to its advanced engineering, it remains one of the safest and most resilient skyscrapers ever constructed. Earthquakes here in Taiwan are a common occurrence, and buildings in Taipei have to be designed to withstand significant shaking. From space, Taipei 101 dominates the city's skyline, standing as an engineering marvel, but what makes it truly special is what lies inside: a 660-ton tuned mass damper, one of the largest in the world. A tuned mass damper is a massive steel pendulum that hangs between the 87th and 92nd floors of the tower. It acts like a counterweight, swaying in the opposite direction of the building's movement during earthquakes or strong winds, effectively reducing vibrations by up to 40%. This damper is essential for protecting the building from both seismic shocks and powerful typhoons. One of the most impressive tests of Taipei 101's earthquake resistance happened on April 18, 2024, when a 7.2 magnitude quake struck Taiwan. Despite intense shaking that caused some older buildings in Taipei to suffer damage, Taipei 101 stood firm with no structural issues reported. This real-world test proved that its seismic design isn't just theoretical, it's highly effective in practice. Also, the aerodynamic shape of the building reduces wind resistance, while the structural flexibility allows it to sway gently rather than resist the force head-on. Combined with the tuned mass damper, it allows the skyscraper to remain stable even in extreme conditions. Viewed from space, Taipei 101 stands as a beacon of modern earthquake-resistant engineering. This is an unmistakable landmark rising above the city. It shows how technology, innovation, and smart design can create buildings that are not only tall and beautiful, but also incredibly strong and capable. Number 13. The Torre Mayor. Torre Mayor, standing at over 225 meters, that's 738 feet with 55 stories, is one of the most earthquake-resistant skyscrapers. It's located in Mexico City. That's a region notorious for powerful quakes due to its location on the Cocos and North American tectonic plates. Mexico City is built on an ancient lake bed, which does amplify seismic waves and makes the ground much more prone to liquefaction. This feature has historically led to catastrophic destruction, such as during the 1985 Mexico City earthquake, which caused thousands of deaths and widespread devastation. Recognizing those risks, the engineers designed Torre Mayor to not only withstand, but absorb and dissipate the seismic energy. One of its most critical features is its 96 massive shock absorbers, known as dampers, which are placed at strategic points throughout the structure. They act like giant shock absorbers in a car, preventing a violent shaking from reaching any critical structural points. Unlike older buildings that may collapse under stress, Torre Mayor is built to bend, absorbing and redistributing the forces to prevent any catastrophic failure. The building's foundations, which extend over 60 meters, that's 197 feet into the ground, further anchors it securely, minimizing any risk of tilting or subsidence. But the ultimate test of Torre Mayor's resilience came on September 19, 2017, when a 7.1 magnitude earthquake struck central Mexico, causing widespread devastation and the collapse of dozens of buildings in Mexico City. While many structures suffered damage, Torre Mayor remained completely unharmed, demonstrating the effectiveness of its resistant engineering. Even from space, Torre Mayor stands as an example of Mexico's engineering advancements, proving that even in one of the world's most seismically active cities, a skyscraper can be designed to protect its occupants from nature's deadliest forces. Number 12. The Sabiha Gökçen Airport Terminal. Sabiha Gökçen International Airport, located in Istanbul, Turkey, is home to one of the most earthquake-resistant buildings in the world. It's situated near the North Anatolian Fault. Now, that's one of the most active fault lines on Earth. This terminal was designed to withstand massive quakes that could reach magnitudes 8 or higher. Turkey, of course, has experienced some of the most devastating quakes in history, with recent events like the 2023 quake, which killed over 50,000 people, serving as a reminder of the country's seismic vulnerability. Given its location, engineers had to create an airport that could remain operational even in the aftermath of a catastrophic quake. The Sabiha Gökçen terminal was constructed using seismic base isolation technology, which consists of 300 massive triple-friction pendulum isolators. Now, these things work by effectively disconnecting the building from the shaking ground, allowing it to move independently from seismic waves. Instead of the structure absorbing the full force of an earthquake, the base isolators shift and dissipate the energy, reducing the impact of terminal and its occupants. The system is so advanced that during a quake, the entire terminal can move up to 90 centimeters, that's 3 feet in any direction, without sustaining damage. And in addition to the base isolators, the terminal features reinforced steel structures, flexible expansion joints, and deep foundations anchored into stable bedrock. Engineers also incorporated redundant power and water systems, ensuring that the facility can continue operating even if the surrounding infrastructure is damaged. The effectiveness of this design was demonstrated on October 30, 2020, when a 7.0 magnitude quake struck the Aegean region of Turkey and Greece. While several buildings in Istanbul reported damage, the terminal emerged unscathed, continuing to operate flights without interruption. From a high-level view, the airport stands as a vital earthquake-resistant lifeline, ensuring that even in the wake of a powerful quake, Istanbul can remain connected to the rest of the world. Number 11. Yokohama Landmark Tower. The Yokohama Landmark Tower, standing at 296 meters (972 feet) with 70 stories, is one of Japan's most resistant skyscrapers to earthquakes. Located in Yokohama, a city that's vulnerable to some of the world's strongest quakes, this tower was designed to withstand massive activity caused by their position on the Pacific Ring of Fire. Given the devastation of past quakes like the Great Kanto earthquake of 1923 and the 2011 Tohoku earthquake, engineers ensured that the landmark tower could endure even the most violent shaking. One of the tower's key earthquake-resistant features is its flexible, reinforced steel structure. The building's designed to bend rather than break, during seismic activity absorbing and redistributing forces across its entire frame. This flexibility reduces the risk of structural collapse. That's a critical factor in earthquake-prone Japan. The most advanced seismic technology used in this landmark tower is a massive tuned damper. This is a system that counteracts the building's sway during earthquakes. And the foundation of the tower is anchored into deep bedrock, preventing liquefaction and ensuring stability even in the event of a strong ground shake. During the 2011 Tohoku quake, which measured 9.1 in magnitude, many buildings in Japan suffered significant damage. However, the Yokohama Tower remained completely intact, with only minor swaying felt inside. From a high-level view, the Yokohama Tower stands as an impressive feat of Japanese resistant engineering, a modern skyscraper designed to withstand the full force of one of the world's most seismically active regions. It does serve as a model for future high-rise construction in earthquake-prone areas over the world, proving that even towering structures can be built to endure nature's most powerful forces. Number 10. The California Academy of Sciences. The California Academy of Sciences, located in San Francisco, California, is not only one of the most eco-friendly buildings in the world, but also one of the most earthquake-resistant. Built in 2008 to replace the previous Academy building, which was severely damaged in the 1989 Loma Prieta quake, this state-of-the-art structure is designed to withstand major seismic activity. Now, one of the best features of this building is the base isolation system, which allows the entire building to move independently of the ground during an earthquake. The structure is supported by over 100 triple-friction pendulum base isolators, which absorb seismic energy and prevent the building from collapsing under extreme shaking. The foundation is embedded deep into the bedrock, which does provide that additional stability against the liquefaction risks, and the design has also incorporated lightweight steel and reinforced concrete, allowing for flexibility while maintaining its structure. But beyond the earthquake-resistant features, the California Academy of Science is a leader in sustainable architecture. It's got a living green roof, which insulates the building and reduces heat absorption, and makes it one of the most energy-efficient museum facilities in the world. The structure also utilizes solar panels, rainwater harvesting, and natural ventilation systems, making it a model for sustainable and earthquake-resistant design. When the next big quake strikes San Francisco, the Academy of Sciences is expected to remain fully functional. Unlike many traditional buildings that require extensive repairs after seismic events, this museum is built to withstand the test of time. From a satellite perspective, the Academy of Sciences stands out with its unique green roof, an architectural masterpiece that seamlessly blends innovation, sustainability, and seismic safety. It proves that buildings don't have to sacrifice design or environmental responsibility to be earthquake-resistant, setting a new standard for future construction in seismically active urban areas. Number 9. The U.S. Bank Tower. The U.S. Bank Tower, standing at 310 meters, 1,018 feet with 73 stories, is one of the tallest and most earthquake-resistant buildings in the U.S. It's located, surprise, surprise, in Los Angeles, California, a city that sits along the San Andreas Fault. It was built to withstand major earthquakes exceeding a magnitude 8, and given the city's history of destructive seismic events like the 1994 Northridge earthquake, the engineers behind this structure designed it to survive even the most intense ground shaking. One of its most resistant features is the steel moment-resisting frame, which allows the building to absorb seismic energy without really suffering catastrophic failure. The frame consists of a flexible steel beam and reinforced concrete core wall, which enable the structure to sway slightly during an earthquake, which dissipates the energy. Another key feature here is its deep foundation, which extends over 18 meters, that's 60 feet, into the bedrock, ensuring that the skyscraper remains stable even in cases of strong ground motion. Its exterior glass curtain wall system is also designed to withstand seismic forces. The glass panels are installed using a shock-absorbing mounting system, which prevents the windows from shattering and causing any dangerous debris to fall onto pedestrians. The tower, though, has undergone multiple seismic retrofits and safety evaluations that ensure it meets modern earthquake standards. It successfully withstood multiple moderate earthquakes over the years, proving that its design can endure real-world seismic events. The U.S. Bank Tower is one of the most striking landmarks in Los Angeles. It's a towering structure that's built to survive in one of the most earthquake-prone cities in the world. It's an example of modern engineering and resilience, proving that even in a region known for devastating quakes, skyscrapers can be designed to keep people safe. Number 8. The Akashi Kaikyo Bridge. The Akashi Kaikyo Bridge. It's also known as the Pearl Bridge. It's the longest suspension bridge in the world, spanning 3,911 meters. That's over 12,800 feet. Not only is this bridge a marvel, it's one of the most earthquake-resistant bridges ever built. Japan, of course, is one of the most seismically active countries on Earth, and the Kobe region, which is where this bridge is located, has experienced some of the greatest destructive earthquakes in history. In fact, during the bridge's construction in 1995, the Great Hanshin earthquake, 7.3 magnitude, struck the region, shifting the bridge's towers by nearly 1 meter, that's 3 feet. Instead of collapsing, the bridge's seismic design allowed it to flex and absorb the force of the quake, proving its earthquake-resisting capabilities before it was even completed. The bridge was built with seismic dampers and expansion joints, which of course allow it to flex during a quake. The suspension cables and towers are designed to move along with the shaking rather than to resist it, distributing any forces evenly across the structure. The bridge can withstand earthquakes of up to magnitude 8.5, making it one of the strongest bridges ever constructed. Plus, the bridge also features tuned mass dampers, similar to those found in skyscrapers, which additionally reduce excessive movement caused by quakes and wind. And from a satellite perspective, the bridge appears as a thin, gleaming thread stretching between two landmasses. It's an amazing structure that defies earthquakes, typhoons, and the forces of nature itself. It is one of the greatest examples of earthquake-resistant infrastructure, proving that with the right engineering, even massive structures can be built to withstand the deadliest seismic forces. Moving on to number 7, the Burj Khalifa. The Burj Khalifa, standing at 828 meters or 2,717 feet with 163 floors, is the tallest building in the world, and now it's one of the most earthquake-resistant skyscrapers ever built. It's located in Dubai in the United Arab Emirates. This tower sits in a region that, while not as seismically active as places like Japan or California, still face the risk of earthquakes from nearby fault lines in Iran and the Gulf region. Now, one of the cool quake-resistant features is the buttressed core design, which gives it incredible stability. Unlike traditional skyscrapers that rely on a simple steel frame, the Burj Khalifa is reinforced by a strong, Y-shaped central core made of high-strength concrete. This type of core can distribute the seismic forces evenly, preventing any single point of failure in the event of an earthquake. Additionally, the foundation is deeply anchored into the bedrock. It sits on a massive reinforced concrete mat supported by 192 deep piles, each extending over 50 meters or 164 feet into the ground. This type of foundation ensures that the tower is going to remain stable even during strong seismic activity. The tower is also equipped with seismic dampers, which help absorb the energy from a quake, and these dampers, combined with the aerodynamic shape of the building, allow it to flex and redistribute energy rather than resist it. Though Dubai has never experienced a major quake, the Burj Khalifa was designed to withstand quakes of up to magnitude 7.0, ensuring that it would remain structurally sound in case of a seismic event. Engineers used computer simulations and wind tunnel tests to model the tower's behavior, refining its design to ensure its maximum stability. And from a satellite perspective, the building is a beacon that rises far above Dubai's skyline. It shows that the tallest structures on Earth can be made earthquake-resistant. It's an example of innovation and resilience, standing as a symbol of human ingenuity. Number 6. The Torre Reforma. The Torre Reforma, standing at 246 meters, that's 807 feet, with 57 floors, is Mexico City's most earthquake-resistant skyscraper, and it's one of the most innovative seismic-proof buildings. It's situated in one of the most earthquake-prone cities on Earth, where devastating quakes have caused major destruction in the past. This tower was specifically designed to endure massive forces. Mexico City is built on an ancient lake bed like we've talked about, which amplifies ground shaking and it makes buildings highly vulnerable to collapse. To counteract this, the engineers created a structure that's incredibly strong but also highly flexible. Its main feature here is its triangular reinforced concrete core, which acts as a rigid spine that stabilizes the entire building. Now, unlike conventional skyscrapers, which often use steel frameworks, this one's core is made of thick concrete walls that can absorb seismic energy without cracking or failing. The walls themselves are 1.2 meters or 4 feet thick, giving the tower an unmatched strength. Also, the tower's split facade design, where one side of the building is left partially open, this feature reduces wind resistance and it allows for the controlled movement during an earthquake, preventing any extreme stress from building up. And of course, the deep foundations are another crucial element in its seismic resilience. Engineers had to drill 60 meters or 197 feet into the ground to anchor the structure to solid bedrock, which ensures that it remains stable. The effectiveness of this resistant design was proven during the 2017 Puebla earthquake, magnitude 7.1, which caused extensive damage across Mexico. While many buildings suffered structural failure, Torre Reforma remained completely intact, showing the power of its engineering. And from a satellite perspective, Torre Reforma is a standout structure in Mexico City, a skyscraper that embodies strength, innovation, and resilience against the forces of nature. It's not only a beautiful building, but also a model for future earthquake-resistant buildings in one of the most seismically active cities on the planet. Number 5. The Salesforce Tower. The Salesforce Tower, standing at 326 meters, which is 1,070 feet with 61 stories, is the tallest building in San Francisco and one of the most earthquake-resistant skyscrapers ever built. Given that San Francisco sits atop the San Andreas and Hayward faults, which have historically produced devastating quakes, engineers had to design the tower to withstand powerful activity and remain operational even after a major quake. Now, one of its most resistant features is the deep reinforced foundation. It's supported by 42 concrete piles drive 91 meters or 300 feet deep into solid bedrock, ensuring that it will remain anchored even during violent shaking. Another key element is the flexible steel frame and reinforced concrete core, which allow the building to bend without breaking during an earthquake. This core acts as the backbone of the structure, absorbing and redistributing seismic forces to minimize damage. It also has a cutting-edge damping system, which helps to counteract the movement caused by earthquakes and high winds. Now, these dampers act like shock absorbers, and they allow the tower to sway gently rather than experience sudden, destructive jolts. And the tower's earthquake resistance was tested on October 14, 2019, when a 4.5 magnitude quake struck the Bay Area. Now, while many older buildings swayed noticeably, the Salesforce Tower remains steady. Its design ensures that even in the event of a 7+ magnitude earthquake, the building will stay standing and be safe for occupants. From a high view, Salesforce Tower dominates the skyline. It stands as a beacon of modern earthquake-resistant engineering, and it serves as a model for future skyscrapers in seismically active cities, proving that with the right engineering, even the tallest structures can be built to endure the world's most powerful quakes. Number 4. The Tokyo Skytree. The Tokyo Skytree. It soars to a height of 634 meters or 2,080 feet. It's the tallest structure in Japan and one of the most resistant towers ever built. Given Japan's long history of devastating quakes, engineers had to develop advanced seismic design to ensure that this tower could withstand quakes while remaining structurally sound. Now, one of its most innovative features is the central shimbashira, or a seismic damping system inspired by the traditional construction of Japanese pagodas. The system consists of a massive central column that moves independently from the rest of the structure, absorbing energy and preventing violent shaking. In the event of a quake, the core will shift in the opposite direction of the tower's movement, which counteracts the seismic forces. Plus, the tower's foundation is embedded deep into the bedrock and ensures it remains stable even during strong shaking. The base is reinforced with a triangular structure, which provides extra strength against seismic forces and even typhoon winds. The effectiveness of the design was put to the test on March 11, 2011, during the 9.1 magnitude Tohoku earthquake, one of the most powerful quakes ever recorded. Despite the intense shaking felt across Tokyo, the Skytree remained completely intact, suffering no structural damage. This event proved that the tower's seismic engineering was not only theoretical, but also capable of withstanding real-world events. And of course, it was also built to withstand Japan's frequent typhoons, which bring strong winds and heavy rain. Its slim design and flexible structure allow it to sway safely in the wind, preventing any excessive strain on the tower. This building is an example of the country's ability to merge tradition with cutting-edge technology, proving that even the tallest structures can be made resilient against the forces of nature. Number 3. The Torre Costanera. The Torre Costanera, also known as the Gran Torre Santiago, is the tallest building in South America, standing at 300 meters or 984 feet with 64 stories. It's located in Santiago, Chile, one of the most earthquake-prone cities on the planet, and it was designed to withstand some of the strongest events ever recorded. Given Chile's history of devastating megathrust earthquakes, including the 9.5 magnitude Great Chilean Earthquake of 1960, the strongest earthquake in recorded history, engineers had to ensure that this could not only survive, but remain fully functional after major events. Chile lies along the Nazca and South American tectonic plates, where subduction leads to frequent and massive quakes. The 2010 Maule earthquake, which measured 8.8, caused widespread destruction throughout the country. Torre Costanera was under construction at the time, and engineers took the opportunity to test and refine the building's earthquake-resistant features. As a result, it became one of the most thoroughly earthquake-proof skyscrapers in the world. Now, one of the most critical features here is the reinforced concrete core. Now it acts as the spine of the building, allowing it to absorb and redistribute seismic forces without suffering any catastrophic damage. Unlike traditional buildings that rely on steel frameworks alone, this hybrid design of reinforced concrete and steel framing gives it an unparalleled ability to resist seismic forces. The building's base isolation system is another key innovation. Large seismic dampers and shock absorbers are installed in the foundation level, which allow the tower to move independently from the shaking ground. The foundation is deeply anchored into the bedrock, extending 40 meters or 131 feet underground, and it prevents tilting, sinking, or excessive swaying during seismic events. Now, one of the most impressive real-world tests of this building happened in 2015, when an 8.3 magnitude quake struck central Chile. Despite intense shaking felt throughout Santiago, the skyscraper remained completely intact with no damage reported. This event demonstrated it is capable of withstanding some of the strongest quakes on the planet. And from a satellite perspective, it dominates the skyline of Santiago. It is one of the safest places to be during a quake, proving that skyscrapers can be designed to remain standing and functional even in the most earthquake-prone regions on the planet. Number 2. The Sutong Yangtze River Bridge. The Sutong Yangtze River Bridge, spanning an incredible 8,200 meters, that's 26,900 feet, is one of the longest cable-stayed bridges in the world and one of the most earthquake-resistant bridges ever built. Located in eastern China, this bridge was designed to withstand huge quakes, extreme winds, and major flooding. China has a long history of catastrophic earthquakes, including the 2008 Sichuan earthquake, which killed nearly 90,000 people and destroyed thousands of buildings and infrastructure projects. Now, given that the Yangtze River Basin is vulnerable to this activity, engineers needed to ensure that the Sutong Bridge could survive powerful quakes without suffering major damage. Now, one of its most important features is the seismic isolation system. The bridge is equipped with advanced seismic bearings, which allow different sections of the bridge to move independently from one another. And the bridge's deep foundations are another critical component of its resilience. The main bridge pylons are embedded more than 100 meters or 328 feet into the riverbed, ensuring that they remain stable even during ground shaking. These deep foundations prevent that liquefaction, that's a phenomenon which soil temporarily behaves like a liquid during intense quakes. But the bridge's towers are designed to sway safely rather than resist any seismic forces head-on. Of course, constructed from high-strength reinforced steel and concrete, these towers are flexible enough to bend slightly during a quake, allowing the structure to distribute stress evenly. Additionally, the bridge is designed to withstand extreme wind, which is especially important given the Yangtze River region experiences frequent typhoons. The bridge's shape, which is aerodynamic, will minimize wind resistance, ensuring its stability even in hurricane-force conditions. But one of the most remarkable real-world tests of this bridge's resistance happened when a 6.1 magnitude quake struck eastern China. Despite the strong shaking, the bridge remained fully intact and operational with no reported damage. This demonstrated that its seismic-resistant design is highly effective in protecting both the structure and the people who rely on it. From a satellite perspective, the bridge appears as a massive thread stretching across the river. This is a marvel that connects two major cities while also defying the forces of nature. It serves as a model for future infrastructure projects in earthquake-prone regions, showing how advanced engineering and meticulous planning can create structures that remain standing even in the face of nature's most powerful disasters. Number 1. The Bosphorus Bridge. The Bosphorus Bridge, officially renamed the 15 July Martyrs Bridge, is one of the most earthquake-resistant suspension bridges in the world. It spans the Bosphorus Strait in Istanbul, Turkey, and it connects the continents of Europe and Asia, making it one of the most strategically important bridges in the world. Not only does it serve as a transportation link for millions of people, but it also sits in one of the most seismically active regions in the world, directly above the North Anatolian Fault, a tectonic boundary responsible for some of the most devastating quakes in history. This North Anatolian Fault has produced multiple catastrophic quakes, including the 1999 Izmit earthquake, which measured 7.6 in magnitude and killed over 17,000 people. If the Bosphorus Strait were to collapse in a major earthquake, it would not only cut off vital transportation routes, but also create an economic catastrophe for both Turkey and the wider region. To prevent this kind of disaster, engineers had to implement some of the most advanced resistant technologies in bridge construction. It was originally completed in 1973, but after the '99 earthquake, it underwent significant retrofitting. The goal was to ensure that the bridge could survive a quake of 8.0 or higher without suffering any major structural damage. And one of the key features that makes it earthquake-resistant is the flexible suspension design. The main cables and suspension system allow for controlled movement, which enables the bridge to absorb and dissipate seismic energy without suffering any damage. To reinforce the bridge's foundational stability, engineers anchored the main support structures deep into the bedrock, preventing them from shifting or collapsing in the event of liquefaction. This design was put to the test during the 1999 Izmit quake, one of the deadliest and most destructive in Turkey's history. Following it, engineers conducted extensive assessments of the bridge and recommended additional seismic retrofitting to further improve its earthquake resilience. In the early 2000s, the bridge underwent a multi-million-dollar reinforcement project incorporating state-of-the-art earthquake-resistant tech to ensure its survival for future events. Another safety enhancement was the installation of high-strength steel cables to reinforce the original suspension system. Over time, regular wear and tear can weaken bridge cables, but by using modern corrosion-resistant materials, engineers can ensure that the Bosphorus Bridge will remain structurally sound for decades. And from a satellite perspective, the bridge is a critical connection between two continents. It carries over 200,000 vehicles a day, and it serves as one of the most important routes in Turkey. If the bridge were to collapse during a major quake, the economic consequences would be catastrophic. Not only would millions of commuters be stranded, but Turkey's supply chain and international trade networks would suffer severe disruptions. This is why ensuring the bridge's long-term earthquake resilience is a national priority. The Bosphorus Bridge isn't just a bridge, it's a lifeline between two continents, a critical piece of infrastructure that's withstood the test of time and some of the most devastating quakes in history. Whether viewed from satellites orbiting above or the streets of Istanbul, the Bosphorus Bridge remains an enduring symbol of resilience. It's one of the safest places to be during an earthquake, proving that even in the most seismically active regions on the planet, humanity can build structures that stand strong against nature's most formidable forces. Click here to watch the next video on the top 15 largest earthquake cracks in the world. Thank you to our channel members.